Thousands of years ago, the very same land you live and walk on today was home to all forms of giants. The Pleistocene epoch, which ranged from 2.8 million years ago up until around 11,000 years ago, was host to various forms of organisms called megafauna, large animals of various species which typically weighed over 100 kilograms each. These megafauna ranged from the well-known mastodon and smilodon, or more commonly known as the saber-toothed cat, to some lesser-known species like the megatherium, a giant ground sloth comparable to the size of modern elephants. Nowadays, though, if you were to look into your backyard or in a park, the only mammals you'd probably find are some rabbits and squirrels. So what happened to these massive mammalian giants? Well, thanks to the fossil record and various ecological studies, paleontologists have discovered a mass extinction right at the end of the Pleistocene, eliminating nearly all megafauna across the world outside of Africa. To explain this extinction anomaly, over the past few years, various scientists have proposed different ideas about the possible cause of this late Pleistocene extinction event, with some hypotheses being more supported than others. One such explanation for this disappearance is the hypothesis that there could have been a hyper-disease which was responsible for the extinction, stating that Aboriginal humans who traveled out of Africa and across the world brought along with them a disease that ended up spreading and wiping out the megafauna populations. To determine this, scientists used the West Nile virus as a proxy for the hyperdisease. They compared the mortality pattern of the disease to that of the megafauna extinction to see if the two end up matching or show a close pattern. But after analyzing the pattern of the West Nile virus, scientists determined that it's unlikely that disease was the cause of the extinction due to the size exclusivity of the megafauna extinction. Where the extinction only focused on large megafauna, a hyperdisease would show signs of significant mortality among various sized species. Another hypothesis, which was proposed back in 2007, was that the potential culprit for the extinction in North America could have been an extraterrestrial impact. The hypothesis revolved around the idea that the meteor impact triggered the period of global cooling during this time, which scientists called the Younger Dryas. The impact and subsequent cooling would then result in heavy climate and environmental change, which would in turn cause the megafauna to die out. To do this, scientists analyzed a carbon-rich layer dating back to 12.9 thousand years ago, dating to the same period as the Younger Dryas and megafauna extinction. Unique to this black carbon-rich layer, unlike the layers above and below it, were traces of iridium, nickel, fullerenes, and magnetic microspherules, all of which act as a telltale sign for a possible impact event at this time. So, was a meteor really responsible for the extinction of megafauna? Well, it's unlikely. 2 years after that first analysis, there was another study to readdress the impact theory. In addition to remeasuring the trace values found in the carbon-rich layer, scientists also looked at oxygen isotopes that corresponded to this time period to find any anomaly or change in the average value which could correspond to an extraterrestrial impact. What these scientists found, though, dealt a large blow to the credibility of the impact theory. Not only could they not reproduce the same values for the iridium and other trace materials, but also the oxygen isotopes in that layer showed no abnormalities or any different values other than average geological layers near it. So with this secondary study, the impact theory is most likely a bust. But while the impact theory is pretty unlikely to be the cause, along with hyperdisease, two hypotheses have relatively more support and data to them, and they are human interaction and climate change. One such theory for human interaction is the blitzkrieg theory, which suggests that these megafauna were quickly exterminated with the arrival of humans to their foreign lands. Since megafauna outside of Africa had not coexisted with humans before, it's believed that they were helpless to the humans' overhunting practices and were driven to extinction. But while there is considerable logic behind this idea, a study on the Australian megafauna extinction shows a noticeable time lapse between the arrival of humans and the extinction of the island's megafauna. Now, you might be thinking, if the hyperdisease and the impact theory are highly unlikely, and the blitzkrieg theory seems to be ruled out by this time lapse, what caused this rapid mass extinction then? Well, recently scientists have taken bits and pieces from each piece of significant evidence and previous theories and hypothesized that the most likely cause of the late Pleistocene extinction is a synergistic effect of both climate change and human interaction, driving the megafauna to all die out. But while these two effects seem to be the likely causes, scientists have found, though, that the influence of humans and climate change vary based on each area. In Eurasia and Australia, climate change probably played the more major role in the extinction than human interaction. Change in the environment and forcing the megafauna to try and adapt to the new world in which they lived in. This forced adaptation would cause significantly more competition and stress. Coupled with human hunting and influence, megafauna would be suffering from a synergistic effect, resulting in species eventually dying out. America, on the other hand, showed much more evidence of human hunting than climate change, based on the larger human population in the area, and evidence of multiple megafaunal fossils that have been discovered with Clovis spear points in them. This stronger human influence on the extinction is present because, based on the previously mentioned concepts, in Africa and Eurasia, humans coexisted with megafauna there for hundreds of thousands of years, while in the Americas, they were considered invasive species, and thus the megafauna had no adaptations to deal with humans. Even though this mix of climate change and human interaction is the current and most probable explanation for why these giants went extinct, there's still much more to be learned about the Pleistocene and what happened. And now, some of you might be thinking, alright, so what? Why is the Pleistocene extinction important? Why does it matter today? Well, just as these animals in the past were being threatened and driven to extinction by the synergistic effects of climate change and human interaction, so are an overwhelming number of species today. While we aren't hunting all of these species today, humans are still significantly reducing their habitats, which alone is detrimental to their survival. But coupled with climate change, that means the little habitat these animals have left will soon not be hospitable for them in the future. But with nowhere to go, we'll start to see a huge number of species begin to go extinct. So can we see another mass extinction event in the coming future? Well, there is no guaranteed way to tell. But with the signs and development we are seeing today, all we can hope for is that we don't end up in another worst-case scenario.